Okay, guys, so let's look at the first of these past paper questions. So the first one says Anne is investigating how the current flowing in a metal wire depends on the voltage across the wire. The temperature of the wire is kept constant. Basically, this question is, can you prove Ohm's law? What's the experiment that you used to do that? So it says draw a circuit diagram using the correct symbols and space below to show the circuit that Anne should use. Now, there's two possible circuits you can do. We can use one that has a variable power supply. Or you could use one with a variable resistor. What we need is an ammeter that's in series with our wire. Now I'm just going to use a little resistor as our wire, but you could use a different circuit if you want. They're all in series, and in fact, I mean, you can put this anywhere in the series circuit. We also want that little switch in there. And I would draw them initially. I would label things in my diagrams and just get into the habit of doing that. And then finally, I would add a voltmeter in parallel across the wire. Okay. Or the other circuit you could use, like we said, could be one that has a fixed power supply. Okay, everything else is the same. We have our switch. Won't label these because they're labeled on the other side. We have our wire that has a voltmeter across it. But then somewhere in that series circuit, we need a variable resistor, because that then allows us to change the voltage and the current across the wire. So the one on the left has one less component, therefore I think it's easier, and that's the one I would probably go with in an exam. Describe what Anne should do to get a series of readings. Change the dial on the variable power supply. If you've drawn the second circuit, change the setting, might be a dial, might be a slider, on the variable resistor. Okay. What must Anne do to ensure that the temperature of the wire does not change during the investigation? Turn the circuit off, so open the switch. Between readings, and that gives it time to cool down. Okay. Remember, Ohm's law, voltage is directly proportional to current as long as the temperature remains constant. So we have to make sure that we do that. Okay. Next part of this question then moves on to a little circuit. Calculate the following. Your advisors show clearly how you get each answer. Total resistance of the circuit, well, they are in series, so it's just 2 plus 6, which is 8 ohms. Calculate the current flowing in the 2 ohm resistor. Now, the common mistake here would be for people to say that there's 12 volts across there and do V equals IR with 12 and 2. But we can't do that because that voltage is going to split between the 2 and the 6 ohm resistor. However, we have said that that circuit is equivalent to a single resistor of 8 ohms. So if I deal with that and do V equals IR with the 12 volts and the 8 ohms, I can then do 12 divided by 8 equals I, which is 1.5 amps, and that's the total current in the circuit, the current that flows out of the cell. And you can see there's no parallel portions there, so all the current flows through the 2 ohm resistor like we're asked, so we can tell that it's 1.5 amps. Calculate the voltage across the 2 ohm resistor. We can do V equals IR. The voltage is equal to the current that flows through it, 1.5, times the resistance, which is 2, so the voltage is 3 volts. Another resistor is then connected in parallel with the 6 ohm resistor shown below. When this is done, the current in the 2 ohm resistor becomes 2 amps. What is the value of this resistor X? Show clearly how you get your answer. Okay. Tricky enough question this, only worth 5 marks as well. Where do I start? Well, where do I have information? I know this is 2 and this is 2, so I can do V equals IR and do V equals 2 times 2, so I know this is 4 volts. So there's 4 volts here. Then what I can do is, looking at this part of the circuit, I can tell that in any one loop of the circuit, the voltages have to give up to give 12. So if I go around that yellow loop, I know that there has to be 4 volts across here. Therefore, what I can do is look at this one and do V equals IR, 4 equals 6I, I equals 4 divided by 6, which is 0.667 amps, let's call it. So now what I know is, if we look at this 2 amps goes to here, and we know that 0.667 amps goes this way, we can then work out how much must go down this path. So I will equal 2 amps minus the 0.667. Remember, whatever flows into the junction must flow out, which is 1.33 amps. And I then also know, if I take this path around the circuit, the voltages have to add up to give 12. So I know that this here must be, and I just realized I've made a mistake, that shouldn't be 4, that should be 8 volts. So 4 plus 8 is 12. So this here should be 8, and that should then be 8 divided by 6, which is 1.333 amps. So when we subtract that, we get that the current on that lower branch will be 0.667. Okay, so let me just change those values. So we have 1.333 along here, and down this way we have 0.667 amps. And we know that if we take that blue path, this is 4. We're trying to find out what this voltage is. Must add up to give 12 when we go on this path around the circuit. Therefore, this must also be 8 volts. It needs to be that because it's parallel with our 6 ohms. So what we can do then is just look at this part of the circuit and do V equals IR for that resistor. The voltage is 8. The current is 0.6667 times R. Divide both sides by 0.667 equals R, which is 12 ohms. Okay. Tricky enough question that. Be careful how you lay these out, particularly when it says your advice show clearly how you get your answer. That way you can get ECF in the question, and you can get marks for working out even if you don't get to that 12 ohm answer. Okay.